Okay, so we're looking at population variance and standard deviation. And first I've got to kind of explain what these things are. So what we're trying to do is see how far away from the mean the data is moving. So it doesn't move a lot away from the mean or a little away from the mean. And we're trying to measure that difference from the mean. So variance is what we call the average of the squares of the distance each value is from the mean. Distance each value of the data is from the mean. Now I know that sounds weird, but let's take a look at brand A for a minute. And so remember the mean for brand A. So we're going to treat brand A as a population right now. And we're going to say the mean is that 35 that we found. Okay, so mu, this is mu, that's population mean. Okay. So if we look at brand A, it had 10, 60, 50, 30, 40, and 20 for its data points. All right. So if I found the difference between that and the mean, so I subtract the mean off of each one of these, and I just subtract the mean off. This is not variance. I'm not doing variance. I'm just showing you something right now. So let's look at this difference here. So this is negative 25. This is 25. What is this? This is 15. This is negative 5. This is positive 5. And this is negative 15. Now notice if we add these all up, they start kind of canceling each other out. And we get 0. That's always going to happen. If you take the data point and you subtract the mean off just as it is and you add up all those differences, you're going to get 0. Because the whole idea is that these things are equally spaced around the mean. Now, the problem is that doesn't tell us how variable this data is, how much variation there seems to be, how much difference there seems to be from the mean. So instead of looking at just the difference between the means, what we look at is we get rid of the negative sign by squaring everything. So here's how we find variance. So the first step in finding variance, well, let's put the formula for a second. Variance is sigma squared, this is population variance. Okay. And it's sigma squared equals, we're going to add up all the differences between the data and the mean, and we're going to square those things. So every time we found a difference, we square it, and then we're going to add those all up, and then we're going to divide by the total number of data points. That's what it means by the average of the squares of the distance. Okay. So we add up all the differences, we find the differences, we square them, we take a sum of all those square terms, and then we divide by n. So that's what we got to do for this. So we're going to go each of the values, 10 minus 35, and we're going to find that difference. So we already did that. Let's put them up here again. So we find all those differences. So this is x minus mu. And so x minus mu is equal to negative 25, 25, 15, negative 5, 5, and negative 15. And now what we want to do is we want to square those values. Okay, so we got to go 25, negative 25 squared. Remember, put it in parentheses, because if you don't put it in parentheses, this should look like negative 25 squared in parentheses. If you don't do that, it's not gonna square the negative the right way. So this is 625. This next one is also 625. 15 squared is 225. 5 squared is 25, 25, and 225. Okay. Now we want to add up all those values. So 625 plus 225 plus 25, 25 plus 225. And that gives us 1750. Now, once we have that sum, we divide that sum by the number of data points that we have. So there are 1, 2, 3, 4, 5, 6 data points. So sigma squared is going to be 1750 divided by 6. So that's 291.67 basically. Now that's not in months. That's in like month squared. So this is the variance. The standard deviation is the thing that we read most often. That's the square root of this answer. So this is variance. And so we want to do, and for that's population variance, and we want to do population standard deviation. That's sigma, and that's the square root of our variance answer. So that's the square root of this 291.67. So we take the square root of that answer, and I get 17.0, let's see, one more, 0.8, okay? And that's our standard deviation. So it says on average, the difference between the mean and the data point is approximately 17.08 months. So that's our standard deviation. Now it's in months. It's in the same unit as whatever our data was in. All right, so let's do the same thing for brand B. We're going to treat it like a population. So we want to take the data from brand B. That's it. We're going to go X. And remember, the mean value was 35. Okay, so we're going to go X minus mu. So 35 minus 35. 45 minus 35. So let me write X down for a second. 35, 45, 30, 35, 40, and 25. Okay, so now we're going to go 30 minus 35, 35 minus 35, 40 minus 35, and 25 minus 35. And so those are 0, 10, negative 5, 0, 5, negative 10. And notice again, if I were just to add these values, I would get 0 out. So the next thing we want to do is then square those values. So 0 squared is 0, 10 squared is 100, negative 5 squared is 25, 0 squared is 0, 5 squared, and negative 10 squared. Okay, and now what we want to do is add that up. So this is going to be 250. So our variance is that sum, 250, divided by the number of data points we have, which is 6. So this is 41.67. All right, so that's our variance, but we really kind of want our standard deviation also, because it's a better measurement, or it's a better interpretation of the difference between the mean and the data points, because it's in the same units as our population. So population standard deviation, which is sigma, and that's the square root of sigma squared. So that's the square root of 41.67. And that's 6.45 months. So the variance here is quite a bit of difference. Up here we have, or the standard deviation and variance are quite different. The standard deviation for sample A was 17 months basically, and the standard deviation for sample B was 6.45 months. So that tells me that the sample A has a much broader range of data than sample B. Sample B's data are much closer together. Okay, so that's how you do it with populations. So the next thing that we're going to do is do sample variance and standard deviation.